Hi everybody, and welcome to a quick aside video where we're going to take a look at how we solve this differential equation for a logistic growth model and how it comes to be that this is the solution here on the screen. Now, in order to do this, we're going to have to use two integration techniques. We're going to have to use separation of variables, and we're also going to have to use a technique called partial fractions. So if you're unfamiliar with how partial fractions work, you should probably go watch that video. So first things first, I'm going to separate my variables. And so the two variables that I have here are p. So I need to make sure all the p's go to one side. And then the other variable I have is a t. The k and the m, those are constants, and I'm going to treat them like numbers. So they really don't affect how I solve this problem. They do, but they don't really. They're not a variable, so I don't need to worry about them. So what I'm going to do is I'm going to divide this entire quantity here over to the other side. I'm going to put dt on the right-hand side, and it looks like this. I'll get p, and then m minus p dp equals k dt. Now I'm ready to integrate both sides. And so when I integrate, the left side, this is where I'll have to use my partial fractions. The right side just turns into kt plus c. So I'm going to do that last. So let's deal with our partial fractions. And this becomes 1 over. Let me make sure that that's clear. So to do partial fractions, I'm going to divide it into a over p plus b over m minus p. And that is equal to 1 over p times m minus p. Now when I go and do the process of getting my common denominator, I'm going to multiply here by m minus p, top and bottom, and then p and p. So now I get this. I get a times m minus p equals b times p, or plus b times p equals 1. Now I'm going to let p equals 0, and when p is 0, I get am plus 0 equals 1, so a equals 1 over m. And then I'm going to let p equal m, and when p is m, this turns to 0, and then I get b times m equals 1, which means b is also 1 over m. So now I'm ready to go and do my integral. So when I integrate, I put a in and b in. I get 1 over m over p plus 1 over m minus p dp. So this turns into the natural log of the absolute value of p times 1 over m. And then this, I have to be careful because there's a chain rule. So this is m minus p. So using a u sub to undo that integral, it turns into a minus m minus p, and then 1 over m is in there. And then there's a plus c, but I'm going to worry about that when I put it back into my big problem. I'm going to put the plus c on the right-hand side. So here's what I have. When I integrate the left, this is what I get. 1 over m. And I'm going to go ahead and combine this. ln, it's going to be p over m minus p. Ooh, tricky. Okay, so that's the left-hand side, equals kt, and here's where I'm going to put my constant in, plus c. Now I'm going to multiply this 1 over m. I'm going to move that to the other side. So I get mkt. And then when I multiply the mkt with c, it stays a constant. So really, I'm multiplying both of them. Make sure you understand I am distributing. But m is just a number. So a number times a constant is going to stay a constant. They kind of absorb each other. So now I'm ready to get rid of these absolute value bars and start solving for p. So I'm going to raise both sides as a power of e. When I do that, I get the absolute value. These cancel away. M minus p equals, and now on this side, I'm going to rewrite this as e to the c times e to the mkt. That looks familiar. So now when I drop these absolute value bars, I'm going to have to throw a little plus or minus in there. So that's what I'm going to do. I'm going to drop these bars, and now I'm getting close. I'm going to call this constant. I'm going to rename it. I'm going to let plus or minus e to the c equal any arbitrary letter. Let's name it a. So here's what I have. P over m minus p equals a e to the mkt. Ooh, now this is shaping up. So here we go. I'm going to multiply over the m minus p. Going to cancel. So now I'm getting close. P equals, I'm going to go ahead and distribute this in. So it's going to look like this. M times A e to the mkt minus p times A times e to the mk. Now I'm going to add this guy over to the other side. When I do that, I can factor out a p. It'll look like this. P times 1 plus A e to the m kt equals m a e m k t. So many letters. Getting close. Now all I have to do is divide. I'm going to divide by 1 plus a e m k t. Divide by 1 plus a e m k t. Okay, so let's think about this. We've got some things happening here, and it doesn't quite look the way that I want it to look. And so there's a trick here that I can do to make this a little simpler. And the trick is this. I can multiply the top and the bottom, because remember, in my solution, I just have m in the numerator. So I can actually take the top and the bottom, and I can multiply them by the same thing. I'm going to multiply the top by this quantity, and I'm going to multiply the bottom by this quantity. Watch what happens. So I'm going to scroll to this side. On the numerator, these will cancel away. So I'm left with m. That's good. M. Now on the denominator, I'm going to distribute this. So I'm going to have 1 over a e mkt plus, and then when I multiply these two together, it's going to turn into a big fat 1. Now, we're really close, you guys. Let's remember that when I have a fraction in a fraction, it's no good. So I can actually rewrite this one more time. And I'm actually going to switch these two around, because in the original it says 1 plus. So I'm going to put the 1 here. Now, when I switch these around, I want to understand that this is 1 over a times 1 over e to the negative, or e to the mkt. So what I'm going to do is I'm going to rewrite that e with a negative exponent. I'm going to bring it up to the numerator and put a negative exponent in there. And then you guys, 1 over a is a constant. So let's just rename it as just a, right? Who cares if it's 1 over a to start with? Really, we should have called our other constant like k or we should have called it something else. But we're going to name it a. 1 over a, it's just a constant. The rules with constants are kind of loosey-goosey right now. But essentially, this is where it comes from. A is just some arbitrary constant. And there it is. So this is my solution. It's not my particular solution. But this is where that solution comes from. It comes from using separation of variables in addition to things like, there's the whole thing. Separation of variables in addition to partial fractions, and just using some crazy mad algebra skills. So do you ever have to do this? Probably not to this degree, but never hurts to try. So keep going with it. You can do this. You've got this.